equals 8. And this fraction bar is meant to designate division. So you undo division with multiplication. What do you multiply both sides by?
2.
Yes, so you multiply both sides by 2. On the left, they cancel, they go away, just like in the previous where we were talking about the -4 and the +4, they go away. These 2's on the left, they go away. So that means x equals 16, like that. So I'm going to give you 4 problems to solve, all one-step equations, and then we'll move on to 2-step equations. Is that okay?
Mm-hmm.
Great. All right, so here we go. Let's go x plus 3 equals 7. X divided by 3 equals 7. And 3x equals 21. 7 equals x minus 3. So I'd like you to solve each of these, please. And whenever you're done, I'll write down the correct answers and you can compare to what you've got.
Is it 4, 21, 7, and 10?
Like this? Yes, that is correct. Just confirming you can hear me?
Yeah, I can hear you.
Okay, great. All right, so those are all one-step equations. You have to be able to solve 2-step equations. So the steps refer to the operations. So the first type of problem that we are going to look at is to add and then divide. So in every problem I show you, you are going to add and then divide for right now. Okay. You look at the side with the variable. Your focus is over here on the left. And remember, you add to undo subtraction. So are you going to add 5 or 4?
5.
5. You add 5 to both sides. 4x equals 8. Now what are you going to divide by?
4.
4. You divide both sides by 4. X equals 2. New question for you. It's the same thing. You will add and then divide. Can you do that for me, please?
31.
31. Okay. How did you, what did you add? Let's start with that.
6 to 26.
Okay, that's true.
Is
So
that
when you add
32?
6, it is 32. And you have to divide from here.
Yeah. I just have to do that on the calculator.
Sure. Yeah,
4.
there's 4. All right, so I want you to try the next 2 problems on your own. They're add and then divide, add and then divide. Not trying to make anything difficult, exactly like what we've just done.
Eight.
Okay. Do you have the other one, or do you need to work it
No,
out?
I haven't done that one yet.
Okay, yeah, give that a try, please. Doing great.
6.
X is 6, good. Okay, so it's always nice when I tell you, when I say you're going to do this and then this, right? It's easy to say, do these steps. And so we got a couple more types to do like that. And then the real challenge will be when you have to figure it out on your own. But let's take a look here. So these problems are subtract, then divide. And again, your focus has to be on the side with the variable. Like, are you subtracting 2 or are you subtracting 6?
6.
Yes. So you first subtract 6. 2x equals 6. Divide by 2, divide by 2. X equals 3.
How do you know how to if you do addition then
Are you asking me like, well, what if you added 6 to both sides?
no, I mean like when it has the multiplication first and then either plus or minus, do you always do the addition or subtraction first before division?
Yes. Yes. You always do. To answer your question, what you're asking is you do addition and subtraction before multiplication and division.
Because I know with the PEMDAS it's opposite.
That's right. So
So I was expecting to do division first.
so it works this way. When you're simplifying, and you can think of simplifying as no equals, you go the PEMDAS direction. When you're solving, you go the other direction.
Okay.
All right, so let's have you look at another problem here. I'll put 2 in front of you now. All right, so these are both subtract and then divide, subtract and then divide.
Two.
Okay, X is 2. Good.
5.
X is 5. Yeah, very good. Okay. All right, so what I'm going to do now is kind of mix these two up, meaning that you are going to see some of each type that we talked about. So let me just throw another problem at you. All right, so the instructions here would say to solve, you want to focus on the side with the variable. And you want to decide, well, what's going on here? Is it, how do you undo this thing that I'm circling? This number, how do you undo what's here?
Um, addition.
You undo it with addition. You're going to add 18 to both sides. Okay. So on the left, it's 7x equals 49. What does that become? What is the value of x?
Seven.
X equals 7. Good. All right, so here's one for you to try on your own. Again, your focus has to be on the side with the variable. Like, what do you see over here on the left side? Or it could be the right side in the next, you know.
Two.
Is that your final answer?
I think so.
Yes. Good. All right, well, I'm just gonna throw one out. I mean, this is the key here is to keep looking at the side with the variable, and that's where your focus is. So you got a 2 here, 4 here. Give this one a try. Maybe there's enough. We've done enough practice that you'll be able to do this without me helping much.
So will this be 2 plus 26?
So is the side with the 2 is 2 positive or negative?
Oh, that's not a minus. Like we're
There's
not
no,
reversing. No, there's a minus
yes,
before the 26. We're not reversing that to addition.
no. Your only focus. You have to look at the side with the variable. That's where your focus is. Don't even. This doesn't matter over here on the right. How do you undo the 2?
Subtraction.
Yes. So you're going to subtract 2 from both sides. Now we haven't done any negatives yet, but negative 26 minus 2 is negative 28. What should we do from here?
Um, divide it by
Okay,
4.
divide by 4. Good, I like it. What is the final answer?
Would it be minus 7?
Yes. So a negative divided by positive gets you the negative, and then you divide the 2 numbers. Good. Right, here we go. Another one for you to look at. Getting a lot of practice in today. I'd like you to try this one on your own, please.
12.
Perfect. X is 12. Good. All right. So we'll look at kind of a gradual, we're just gradually increasing kind of the complexity of these problems. And one of the things you'll notice is that I can change the variable. Like it doesn't have to be X, it could be U, it could be T, it could be anything really. Your focus is always on the side with the variable. And we talked about at length, you undo addition and subtraction before multiplication and division. So even though it's a -5, you're undoing subtraction by 10 first. What should I do to undo the subtraction by 10?
Add.
Add 10 to both sides. So on the left, it's 70. On the right, it's -5u. Now, you divide by whatever is in front of the variable, which includes the negative. So you divide by whatever's in front, -5, like that. So what does u equal in this case? What is 70 divided by -5?
-14.
Yes. All right, so let me get you one here to try. Doing great. You've got to keep kind of trying these. There's just subtle nuances in each of these, so it's good that you're taking it slow and you're getting the right answer each time. That's what really matters here. So give this one a try, please. Just give me the final answer whenever you have it.
Was this one not even?
This one does work. Perhaps a signer. Did you add one to both sides?
Yeah, wouldn't that make it oh, I went up. I made it -14.
Okay. What would the final answer be?
-4.
Close. You're dividing both sides by -3. So you have two negatives. That means the final
Maybe
answer is
4.
positive. Just 4, yeah. Okay, let's go back here and try a couple more. This one's really similar. Just throw this one at you. We've got to get this down. Like this leads to all the other types of problems you'll see. So we're solving a bunch of two-step equations right now. Always focus on the side with the variable.
Negative. No, regular 5.
So you're just going to say 5 is your answer. Subtract 1, subtract 1. -15 equals -3k. Divide by -3. And yes, k equals 5. Good. So what I'm doing now is I'm just question.
I put it in my calculator, and the calculator put it as -5 as the answer, even though I put negative signs in front of both the numbers. I don't think it was supposed to.
That is odd. Yeah. Always good to check your work with what you think is reasonable. Okay, so I'm just going back and forth. I'm just trying to increase the difficulty here because I don't want there to have any questions when we get to the applications of these. Again, you focus on the side with the variable. I can't say that enough because it is super true. What do you undo first here?
You add 14.
Yes, add 14 to both sides. So go ahead and do that and see if you can solve it from here.
And that's just positive 14.
Yeah, I mean, you said it, you're adding 14, and that is true because you're undoing whatever's there. Undoing it means changing it to the opposite, and it always goes away.
Negative 10.
So you have negative 30 equals negative 3q. What are you dividing both sides by?
Oh, wait. I thought that was I didn't realize that was negative.
It's okay.
And it would just be 10.
10. Good. All right. So here's kind of a new problem, kind of related to what you were just asking me. There's a number in front of x. This says 3 minus x equals 14. There's really a number in front of x. It's 1. It's really -1 times x. And I would recommend strongly that you write that in for a while because it's easy to miss that part. Now, when you focus on the side with the variable, what do you undo first?
Add 3.
3 is positive. Remember, there's really a plus that's unwritten here.
Oh, so subtract 3.
Subtract 3. So now when you bring this down, very important, it's -1x equals 11. Is that clear? That -1 comes down with the x?
Yeah.
So we're going to divide now both sides by -1. You always divide by whatever's in front. Even if it's just a -1, you still divide by it. So it looks like this here, x equals -11. So we'll look at a couple more together. I know that these are a little weird, a little wonky. So here's a new one. It's the exact same steps though. It's -1. Treat it as -1. Write it in. That way you don't make the mistake of forgetting about it. Is this 2 positive or negative?
Positive.
Yes, because there's really a plus there. It's just not written. You might wonder, why isn't it written? Well, it's the same reason that the 1 isn't written. Like there's in math, there's certain things assumed, which doesn't help students, but that is the way it's written. So how do you undo addition by 2?
Subtract.
Yeah, subtract 2, subtract 2. So you have 4 equals -1x. What do you divide both sides by here?
1.
What is in front of x? It's more than 1.
-1.
Yes, yes, you have to divide both sides by -1. So this is -4 equals x.
Okay.
All right, so you ready to try one here on your own?
Mhm.
Okay. All right, here you go. Give this a try.
11.
Okay, so yes, I believe that is correct. You subtract 7 from both sides, negative 11 equals negative 1x. Divide by negative 1, x equals 11. Very good. All right, got one more for you. Although I think we did all these. Nope, I guess we didn't do this one. So here's one more for you to try. And then we'll switch to some more two-step equations.
-5.
Yes, very good. Okay, this is great. You've got it down. Okay. So the next two problems here, next two types, that we're going to go back to what we're doing, where I'm going to give you a bunch of the same, because I want you to see that like there's only so many ways you can solve these things. This one says to add, then multiply. So you look at the side with the variable. What would you add to both sides?
Two.
Yes, you're going to add 2 to both sides. This is x divided by 3 equals 6. How do you undo division?
Multiplication.
Multiplication, you multiply by the same number.
So it would be 6 times 3.
Yes. So x equals,
18.
yes. All right, so here's another one for you to try. Put it right next to it, for this one here. It's the same thing, add, then multiply, add, then multiply.
-28.
That's 28, good. All right, so now just to kind of mix this up a little bit, it's the same thing. You're going to add, then multiply, but your focus always is on the side with the variable. Don't be distracted by what's on the other side of the equation.
Negative. -54.
Yes, k is -54. Really good. So the only way to kind of make these more difficult now is to show you kind of another notation real quick. And then we'll look at the other type, and then we'll mix it all together. But this is still an add then multiply problem. You look at the side with the variable, you say, okay, I'm going to add 21 to both sides, add 21. 10 equals 1/6 times s. So this is just notation. It's just a different way to present this. So what I mean by that is this thing on the left is the same as 10 equals s divided by 6 on the right. These are exactly the same. They're solved exactly the same. You can just write things two different ways. So on the right, how would we solve this? What would we multiply both sides by?
I'm confused. Why is it 5/6 now?
This is an s.
Oh,
This is an S. Sorry, my S's don't look as good as the. So let me change it to a cursive S. Oh, or let me just go X. X would be better. How do we solve what's here?
I multiply?
And what do you multiply by?
I don't know.
Okay, let's take a look at the previous problem. What did you multiply by here?
The 23.
Nope. I mean, you got this one right. I mean, maybe okay. So let me write this. All right, let's go back here. What did you multiply this by?
Itself?
Yes. You multiply whatever's on the bottom. So what number is on the bottom?
6.
So you multiply both sides by 6. So X equals 60. Okay. I didn't expect the notation to be an issue, but that's okay. It's not an important part of what we're doing. Let's get back to what we've been doing, which is
Well,
you solved.
how does it affect the final answer? Does the one not have anything to do with it at all?
They're the same. They have the same answer. My concern is that we're going to get sidetracked by just a slightly different way of writing it, and I don't want to do that because it's going to take away from you just doing more problems. These are exactly the same. This right here is the same as this right here in the boxes. They're exactly the same. They're just written differently. It's like you see this every once in a while. Liter is Liter, and it's also litre. And there's a million things like that where it's like, yeah, those are the same. We know that they can be presented two different ways.
Okay.
Remember, there's really a 1 in front of the X. That's why they're the same, because 1/6 is the same as 1/6. So I apologize. I really don't want that to become a distraction. So let's solve this one again. You're going to add, then multiply. So could you try solving this one on your own, please?
Negative 81.
Okay, so now we're going to move to a different type of problem. And then if we have time here, we will put it all together and do a mixture of everything. So here we go. These are now all subtract, then multiply. Subtract, then multiply.
So it would be 1 minus 4.
Yep, you're subtracting 4 from both sides. Very good. So it's X divided by 6 equals what number?
Negative 3. And then
Okay.
you would times that by 6 would be negative 18.
Yes. Okay, so let's see here. Got a couple. I'll put 1 or 2 in front of you, and then we'll go for the mixed review. So same thing here, subtract and then multiply.
55.
Yes, it is 55. Good. All right. So do you feel like you're ready to kind of put it all together, or what do you think will be? Because I want to kind of throw a bunch of different questions at you that we've all done tonight, but I don't want it to be overwhelming. That's
Yeah, I
kind of
guess
where we're at. Go
let's
ahead.
just throw them all together.
Okay, let me do that here. So I don't actually have just a review on this. I gotta just quickly grab a worksheet from the internet. All right. Okay, here we go. So these are in no particular order. There's no like it's this and then this. It's you have to look at it, look at the side with the variable, and decide how to proceed.
I do subtraction, right? Subtraction first. That's it, because that's a -6. But the
How do you
plus is,
undo? You undo subtraction with addition.
oh, so that addition sign right there doesn't mean anything.
It's always to the operators to the left
Okay.
of it. So the plus actually goes with the x plus 4. The negative goes with the 6, or subtraction with the 6.
Would it be 4?
It is 4. Very good. All right, I'll throw another one at you here. Try to, trust yourself. Don't get too bogged down by it being maybe different than what we've been doing, but you can do all these. These are all problems like we've done tonight. So focus on the side with the variable.
Would the answer just be 0?
Yeah, very good. All right. Give this one a try, please.
There's no sign before the 4.
Okay, so if it's not written, what do we
Is it a
presume it to be?
plus?
Yes, yes.
+20?
Close. Try again. What did you do to undo the plus 4?
Oh, wait. There's a minus sign. -20?
And it's -20. Very good. This is really good practice. I think you're seeing a lot of all the variations we've talked about. Here's a new one for you to try, please.
Is that -6?
Are you asking, is the answer -6 or is this -6?
Is that a -6?
Yes, yes, it goes with it.
Is this one not even?
It does work out, I think.
Let me try it again.
Let me check here. I didn't actually check, so you may be right. No, it does work. It's just not. So is the 10 positive or negative? That may be the issue there.
Positive?
Yes. So how do you undo it?
Subtract?
Yes. So you subtract 10 from both sides. What does the right-hand side become?
114.
Yes. And
I
that does work out. Divide both sides by -6. What does V become?
-19 or 19?
The negatives cancel out. So it
So
is
just 19?
just 19. Good. Okay, get at least one more here. Here's another one for you to look at.
-9?
It's -9. Very good. All right, let's try one more. This might be the last one for today. We'll see. But you're doing great. Definitely have mastered this topic. So give this a try, please.
Ten?
It is 10. Very good. All right. Well, I think that'll do it for us for tonight. Go ahead and stop the recording right here.